Like it is an interdisciplinary field, like people from different engineering backgrounds or science backgrounds can combine together and form some new kind of things in the form of IoT. Basically, the basic fundamental things which needed in case of IoT is like the sensors or the smart devices or the cameras, and like the cloud environment, and at the end the connectivity. And the most advantage of this IoT is that human intervention is almost eliminated. You can control from anywhere, anytime. So, like detailed deliberations and discussions will be given by the today's speaker, Dr. Satish Kumar, because he is an expert, and as an institution, he is working in one of the prestigious institution of the country, like CSIO Chandigarh, who has given very good scientists. And Dr. Satish, we would like to deliberate or discuss the highlights or insights of edge computing and IoT. So, not taking much time or on this, like this very topic IoT, I would like to hand over my mic to Devanshi. So thank you very much for giving me this opportunity. And once again, I would like to thank to all of you of joining this webinar today on edge computing and IoT. Good luck.
Thank you, sir, for sharing your extreme knowledge with us and for your kind words. Now, I'm pleased to introduce today's speaker, Dr. Satish Kumar. And today we are so graceful to share this virtual stage with the principal scientist, which will be going to introduce us with the edge computing and IoT, the need of an hour, bringing new level of industrial internet to the technical reliability and optimization. Before I hand the screen to our presenter, I have a few housekeepings to cover your active participation, which is way too important throughout the session. We have everyone on mute to avoid background noises. If you have any questions regarding the webinar presentation, please type them into the question box in Zoom chat box panel, which is accessible to everyone. And I will bring the questions up with your names at the end. Now, without further ado, let's understand computing infrastructure that exists close to the source of data. And now we will turn the time over to the presenter, Dr. Satish Kumar.
Thank you, ma'am. Is it visible to all? Hello?
Yes, sir.
Is it visible to all?
Yes, yes, yes.
Okay. Thank you, ma'am. So I am really thankful to the VC sir, Professor Tankeshwar, to spare time to be part of this discussion. And also I am thankful to Professor Dharmendra Kumar, who is heading the incubation center, and the chairman, another Dr. Dharmendra Kumar, Jai Bhagwanji, and other faculty and students. See, today we are living in a computational world. That's why Professor Dharmendra Kumar, Professor Tankeshwarji mentioned about Industrial 4.0, as well as no human intervention. They talked about smart city. So one more thing here I want to mention, made specifically because this is organized by the computer science department. And I'm saying we are living in a computational world. See, initially we were talking about only computer science was responsible for doing analysis, programming, intelligence part. Now you see, we are talking about a computational chemistry. We are talking about a computational physics, computational mechanics. So every sector, I am saying, whether it is related to mechanical, nanosciences, whatever be the new, even subject is coming up, mechatronic, everybody is using a lot of computation and AI. And this is really a great thing because you are aware of that this cannot be possible without the intervention of AI and the computation part, and also within the device. That's why this is really an important thing. So today we are going to have a discussion on edge computing and IoT. So I am going to tell you what is edge computing, what are the IoTs, what are its application. My last end of my topic will be on the various application because people may be working on different kind of area. And for computer science student, I want to say that you have to break the barriers. So you can be connect with the chemistry related problem, you can be connected with the medical related things, you can be connected to the electrical discipline, because lot of condition monitoring through thermal imaging is possible. And you have to connect with agro related, optical related, so there should not be any boundaries. The best example is a mobile phone. You know, mobile phone is having a nano surface is also there, nano finishing is there, electronics, computer, so many things are there. So if you will not break a boundary, you cannot work like a team. So because a technology is a involvement of electronics engineer, technology mechanical engineer, and many disciplines. Okay, so we are living in a golden era of computing. Like golden era, why we are saying golden era? Because we are lucky enough to have everywhere a lot of devices. Now also we are communicating over the virtual communication, right? So general purpose graphical processors are available. When general purpose processors are available at the low rate also, but computation speed, for example, like Toradex are there, we can take up even the image processing aspect real time and also generate a lot of features as well as computation part into a device, into a chip. And also there is a superior software methodology. It is not only one particular very small miniaturization of operating system, and also specific tools are available which can be part of our device. And also virtualization, leveraging of the lot of powerful hardware, electronics people is aware of that. They need a lot of computation in terms of a ARM processor, in terms of a FPGA processor, in terms of a GPUs are there, and wider bandwidth for communication. So wider bandwidth, we are having a call, video chats, right? Similarly, we can have an interaction, dissemination of information to the society. Because ultimately, if your device is not disseminating anything to the society, then it is very difficult because of no use. And another thing is that there is a proliferation of devices are there. Lot of devices are coming up. Lot of device want to connect with the internet. Lot of device want to share. Lot of device want to connect it. So exploration of domain of application. So I'm saying no application is where computer science computational aspect is not affected. That is why this is the era of a golden computing. And also the digital world is changing. See, there are more device is coming online. Everybody want to be online. That is why you are aware of that. From IPv4 to IPv6 we are coming because of the need of the devices. More addressing is required. And device gathering more data, because everywhere we want to have a deep neural aspect. We do not want to involve human intervention. We want to remove. So human perception and cognition, that is very important. How we will incorporate that as an inbuilt part of the device. And another thing is that there is when need is increasing, our greed is also increasing. So what we want, we are increasing demand for low latencies, because we do not want to wait for a longer time. We want the information should be available at the click of button at the earliest possible, even the millisecond, microsecond kind of a time. Then machine learning is the mainstream. Everybody want to distinguish, they want to detect, they want to classify, they want to recognize. Lot of aspects are required. And because we cannot develop any technology without the sensors. Sensors are playing very important role. If computer students do not want to understand the depth, at least the data generated by them, how they are being coming together so that they can have a analytics, data analytics over there. And one of the important thing is that data privacy, because data security and even the biomedical field, this is very important because individual patient is involved. Their data is very important, but we have to use the data for research. So how privacy regulation will be maintained? Ethical things should be there. So timing is key, right? For example, Amazon is there. Their HTTP delay is 1 second, but we can say okay, 1 second we can have a 30 rotation of a machine. So I'm saying in millisecond, microsecond kind of a thing is also important. If you are saving with a 1 millisecond and that iteration is going to be 1,000 times, we are able to save 1 second kind of a time. So timing is really a very important if we are having n number of iterations. So as VC sir is also saying about the industrial 4.0. So industrial revolution is coming. So we were in the first era when it was a machinization was there. In second, there was a electrification was there, and then modeling and automation. But the fourth one is a transformation and virtual reality. Whether there is not only optimization, automation, and there is a lot of supply chain, blockchains, big data, right? Physical internet, then autonomous vehicles are there. If you will go to the Frankfurt, you know, no driver is available. Even the tram in the Europe, nothing is available with the load sharing and automation thing they are maintaining. So everything is detected inbuilt. So automation, analysis, and optimization are very important for the industrial revolution that is known as a industrial 4.0. So when we are saying era of a industrial intelligence, what exactly is there? It is a digitization of things, because internet of thing mean what quantity you are going to measure. Human intervention is not required. Environmental digitization and different applications. So ultimately data generation is there. Data generation can be from environment, can be from different then, and it can be cognition and perception will be there, and from different sensors. So what ultimately we are going to have in network, and network based data flow will be there. It will be from local to the regional, regional to the global one, so that information will be available not only restricted to a particular zone, but from anywhere. And we can correlate one kind of a variable with the another kind of variable to generate the intelligence part. So if we are generating the intelligence, so we are going to have a smart analysis, smart decision making, smart operation, and smart optimization. When we are having smart, it means AI analytics is already inbuilt part. For example, if a sugar industry is there and a sugar cane is coming, and we are expecting an amount of sugar to be produced, but we have been getting the n minus delta x kind of an sugar. So we want to study from where the different losses are there, where there are different kind of processes are possible. Similarly, from optimization point of view, industry, how much maximum number of units can be produced with a minimum efforts. So the industrial 4.0 consists of a autonomy. It consists of a autonomous system, so that there will be a self-diagnostic. For example, I will take an example. For example, if we are having a complete network, a pipe or a plant is there which is producing the beverages, and if we consider 25-degree as a abnormal temperature, right? One thing is that if we have detected a temperature of a 25-degree and we have given control to the center recording station that my observation is 25-degree, what to do, right? Then we are waiting, the latency will be more. In the meantime, the temperature may become 26-degree and complete wastage of the complete beverages. So that delay is not acceptable. That is why there is a need of a edge computing. At there only it should shut down and then inform only center recording station that I have shut down this. Automatically self decision it should take. Autonomy is there. It should, depending upon, it should be distributive. It should not be centralized. Control is there. Then there is an internet of things are there. Internet of things we will study in detail. What is internet of thing? Thing means sensors. So ability to connect many devices. New business models are there. And flexible manufacturing means flexible manufacturing, even the component, even the part, even the bones are nowadays being manufactured. And when we are saying a bone is being, like take example of a femur part of a bone, right? A person may be of a 100 kg weight, person may be of a 50 kg weight. So both the design will be different. How we will come to know that? We will take information from the CT scan, and then we will model according to the weight of the person, according to the gait analysis of the person. This is not like that a simple n number of bones to be produced which will be taken care. Otherwise there will be problem with the 100 kg weight, right? So we have to see all that kind of aspects, specific drugs, specific component, specific bone part. Otherwise we cannot have a generalized thing into that. That is only possible with the intelligence analytics part. Then services, of course, we are providing through the internet. And the most important thing is the analytic and cognitive things. How we will come to know which part to be manufactured, what kind of a different degree of freedom should be there. We have to predict, prediction is there. What kind of a thing, whether it plant is going to be fail, plant is going to produce what. There are a lot of prediction model are there. And it is self-learning from the experiences. We are training our network, we are making this self-learning and ultimately communicating to the user. So the salient feature of an industry 4.0 are that it is giving us an innovative product system. When we are saying innovative, there is self-configuring, additive manufacturing, right? And there are ICT like big data, cloud computing, right? And sensors are there. Lot of sensor. People are not only interested in one kind of a data. People are interested even the secondary data for its research, because they want to know even the second layer, third layer kind of information, which is not possible to give with a single sensor. So people want multi-sensing, multi-modality, multi-discipline kind of a thing. Not only physical sensor, also the chemical sensor, also the environmental sensor, also the humidity, also the what was the temperature at that time. So there are n number of factors are there. For example, image processing data we are taking. We are also taking the environmental consideration along with the data. So ultimately robotics are there. So they are the different kind of a salient features. So our topic, that is edge computing and IoT. So first question comes, what do you mean by the IoT? So IoT people have explained so many things, but component point of view, I will explain you a lot of things. Like IoT, it should have identity. Identity, why identity is required. Take a simple example. We want to develop a system for environmental monitoring aspects, right? And in a city, like take care of the Hisar, if we have installed a one sensor in Davda Chowk, another sensor in the university, another sensor maybe model town. So which sensor is having maximum thresholding? Which sensor is generating the data? Whether it is a continuous one or it is a triggered one. If triggered one is there, which sensor? ID is a particular for the location. Similarly, physical attributes, whether the raw data is acceptable. If raw data is acceptable, then entire city, we are talking about a smart city. So it means all sensor is dumping data to a center recording station only. Then central recording station is keeps on taking data from n number of sensors. But how it will process? How it will decide which data to be processed? Rather than processing at the center level, if we will process at the edge level where sensor is placed, right? Then only meaningful information in a low latency can be given to a user, right? And another thing is a use of a intelligent interfaces. This is very important. You have to understand with who, which user you are considering. Whether you are targeting a blind person, if you are targeting a blind person, whatever GUI you are going to incorporate, it is of no use, because he cannot see. He can only listen, he can only convey, or he can have a touch kind of a thing, right? Similarly, take example of a biomedical thing. If a person is a paralytic, right, he can only move the neck, right? Sometimes ball movement can be there, right? Sometimes stylus is available, right? Whether neck movement a wheelchair can drive. Nowadays, very important thing is coming up with BCI, brain computer interface. People are driving the brains, drones through the BCI. Then important thing is to find out the cognition load, understanding the theta, beta, lot of parameters are there, which is to be extracted from the brain interface, the brain signal. Another thing is a Siri, you are aware of that. iPhone user, they are aware of that. Siri, by speaking only, lot of things is being speak. So interface is the most intelligent interface you will have. Your product will have the maximum scalability as well. So even you can say, ki, I am having 3 interfaces, whatever be the user can decide, they can have. So there is a lot of requirement people need to work for the intelligent interfaces. Another thing is that they are seamlessly integrated. When we are saying the seamlessly integrated, so what we are doing, we are dividing our sensors into the different zones, like primary sensors, like secondary, because power is most important if we are dealing with environment. We cannot, for example, take the case of a camera, right? Always camera is on. You are aware of that lens is there, it will not survive. The power is more and continuous data is being generated. Do you think it should be on? Then there should be some other sensor which, if it will, I'm taking a very good example, take a surveillance system of a GJU university. Okay, what I will do, I can switch on my camera always. So what it will do, it will always dump a data. Offline recording will be there, or somebody sitting, they can only visualize. I'm not talking about this. As Professor Dharmender said, no human intervention. I am saying for this safety and security, no human intervention is there. Once intruder is entering into the no man's land or no vehicle zone, automatically it should give me alert on my mobile. Think of that application. Then at that time, I cannot switch on my camera always, right? Because lot of computational load will be there. What I will do, I will place some vibration sensor, right? They are not requiring any power, a very less kind of a thing. If something is triggered, then only I am switching on my camera, right? Even if there may be false triggering may be there, but how much time? Maybe 50 time in a day, maybe 10 time in a day, rather than 24 into 7 switching on the camera. And only we will process the less frame rate, because when image processing students are aware of that, 30 hertz, 60 hertz, even 100 hertz, people are taking care, 100 frame per second. When we are saying it will be processed with the 5 frame per second, because at edge only we have to process and identify the presence of a person. If presence of a person is there, then IoT comes into the picture. Which protocol, how to communicate to the user, whether the location or along with the picture also, depending upon the selection criteria of the user. So what ultimately we are doing, we are generating an information network. This is an information network connecting with the vibration, connecting with the camera, and also connecting to the mobile phone. So what we have generated the information network. If any intruder will enter, then automatically it will be there. So we will generate an alert and alert system or warning system there. So therefore, information network, how much information is being generated, how many information is to be disseminated, how much information is required. Because it should not be like that, okay, plenty of information we are giving to a user. Only the required information to be given. Who is going to support that? It is the edge computing, which we will discuss in detail. And another thing is a dynamic global network infrastructure. As I told you, we are not only restricted to the local one, we are restricting working for the regional, we are working for the global. Like that, independent devices are there, they are having IP connectivity, and they can be independently, if required, data can be taken up. Otherwise, they are continuously working. Self-configuring capability, like for example, if we are moving from one place to another, like that sensor network, they are connecting depending upon the requirement, they are not required. So it's a virtual thing we are making, virtual network we are making. An important thing is standardization. When we are going for a big kind of applications, then standards, what are the communication protocol, what are the standards, how data to be stored. Otherwise, for example, A community is there, B community, they are storing differently, then of no use. If some standard is being followed, directly it will be helpful for our standard software can be incorporated. So if we will combine them, identity, attributes, interfaces, information network, standard, communication protocol, self-configurable system, global network, physical things, all comes in the definition of Internet of Things. So IoT basic means when internet people have understood. But what do you mean by thing? Thing mean what is the quantity, what is the physical parameter we are generating? And this will be through the sensor only. Therefore, temperature, pressure, electronics people and biomedical people are aware of it. But computer people also try to understand the connectivity, the wireless sensor network, and different kind of a quantity as per the agri application you are targeting, medical application you are targeting, environmental application you are targeting, what exactly information you are targeting. According to that, whether it is a aeronautical related application, strategic related application, societal related application, that need to be taken. So thing is a sensor which is generating a particular quantity for you. So in IoT, four thing is very important. If we will consider data, this data is a very valuable for the scientist or for a professor or for a student doing thesis work. The more data you will have, you can generate a good algorithm. Authenticity will be there. Your thesis work will be highly valued. Your research also, publication also, depending upon how much realistic data you are generating. And that data is only possible because of the sensors. What kind of data, whether primary data only, secondary data also. As I told you, people are interested in environmental data when they are storing the image of a scene, right? Video they are generating, they are also taking care humidity, they are also taking care temperature, right? At different time also interval. Another thing is people to whom we want to connect, because when we are saying a technology, it is for a farmer, it is for a doctor, it is for an expert, or it is for a learners, kids also there. Because now, because of the COVID, everything is becoming online, right? So which thing is required, whether it is for kids or for a blind person or for a paralytic, means disabled person, right? Disability is also important thing which need to be taken care. Elderly things are there, you are aware of that. There may be problem to the elderly system, right? Elderly person. So technology interfaces everything depending upon which people we are going to connect. And then thing is that thing is generating the data. Physical device, they are having intelligent decisions. Ultimately, the process is very important. The algorithm, which is a inbuilt part of the system. So IoT consists of four things is very important. That is data, people, thing, and process. Now, somebody may ask what are the different enabling technology for Internet of Things. Internet of Things consists of all these things, like sensor network, because thing quantity is being generated by the sensor. Embedded system, I am saying because all things data is being generated, sensor is being connected to the processing unit. And also intelligent decision is, it is also having AI analytics into it. Cloud computing may be there because we are transmitting data to the cloud. Discovery services, what services it is providing, network information, how the system is integrated, right? Which software you are going to use, whether you are developing your software or some tools are available as an inbuilt part of the communication. Communication, whether you want to have a VSAT communication, GSM communication, spectrum communication, which communication you want to have, right? So that is also an important. LoRa you want to have. Nanoelectronics, because outer layer is very important. We want dust repellent mobile system. No dust, no oil should be there. Even the clothes, textile is also coming like that. No dust will be there. Even if ink will be spread, it will be discarded automatically. So that kind of thing is required for the devices. Of course, standard is very important. I told you which standard you are following. Standard is always very important. And knowledge aggregation, which knowledge you are extracting and integrating them. Future internet, we are not talking about IPv6, we are talking about IPv6. And security is very important. So IoT consists of all these specific technology, maybe even beyond that. So it is, if we will consider, three things is very important: technology, then software and application. Technology may have sensing, embedded processing and connectivity, and the software which we are designing, how that quantity will be taken care. And then application, we can make smart energy, smart parking, as Professor Dharmender said, okay, we are talking about a smart city. So we are talking about a smart lighting, smart car, smart tag, right? Smart health. So everywhere technology innovations are there. So that is only because of the IoT. When we are connecting to the different people, connecting to the sensors, connecting to the even air qualities are there. So we have seen the computing era, we have seen the IoT. Now what is the edge computing, why it is required? I told you because rather we have taken an example of a 25-degree in a beverages plant, when continuously data is being dumped into the center recording station, waiting. In the meantime, it may blast, it may be a number of abnormalities there. Then rather than waiting for a centrally controlled thing, we are making a distributive intelligence that decide yourself and then only report, okay, I have done this thing. So that is more beneficial. And another thing, a traffic system, continuously traffic are coming and continuous data is being dumped into the server. It is not aware of what to do with the data. And sometimes security is also important. So what we are preferring, we are making the edge. Edge mean where sensor is there, from where data is being generated, there only we are placing the processing unit and intelligence part. Now only the processed information in a particular format, in a particular protocols we are giving, okay, this is the prescribed information for you. So question comes, what is the edge computing? So people have given different kinds of definitions. For example, Wikipedia has given, okay, edge computing is a distributive computing paradigm. We are not talking about the centralized control computing. Here we are talking about the distributed. Across the plant, different kind of segments are there, different kind of modules are there. They are taking care, right? So it is a closer to the location where it is needed. No need of a centralized thing. So edge computing, Gartner is saying, edge computing facilitate data processing at near to the source of generation. Near to the source means where it is being generated the data. Edge computing is the ability of processing critical data locally. Critical data, for example, a human health is there. I am having my mobile phone. My shirt may have a different electrode and they are generating different data. Now that data is not dumped into the doctor's control or hospital control. My mobile is having all the processing unit. It is generating. If some threshold is high, then only it is informing my health is not good. So that kind of a aspect is required where no autonomy will be there, no human intervention will be there, secure data will be there, and edge mean at the edge level only the processing will be there. So there will be an involvement of it is a new computing paradigm. It is having Internet of Things, it is having machine learning, and it is having big data analytics as an inbuilt part of a embedded system. So we can call a edge between the cloud and the data. Previously, what was there? Data is being continuously being dumped into the server. Now here edge is there. It is taking care which information, filtered information, processed information, and whether it is a secure information in which form it is to be given. So this edge is very, very important point of view. So because you are all are computer student, we are talking about the OSI layer, right? 7 layers are there, physical, connecting. So edge computing is also divided into the 7 layers. The first one is the IoT thing, physical devices, like physical layer is there, where we are talking about the edge. Sensors are there, devices are there, intelligent edge node are there. They are automatically connecting, correlating the things, and then communicating, connectivity, and then edge computing are there. And automatically what we are going to have, we are going to have a data abstraction, and also what application we are going to generate. Finally we are giving to the pupil, we are going to the servers, we are going to the different kind of a thing. So with edge computing, what is important, what edge computing totally involves? See, there are a lot of operational technologies like wearable, car, motor, building, right? Mobile devices, meters. Okay. Now what they are going to have, they are going to have early data analytics, early warning system. For example, everybody want to have their health. Once a professor asked, every time, when my printer is there, ink is not there, it start telling my ink is very low, right? Because of it is continuously checking the cartridge. But whether your fridge is telling after 2 days my gas will be deteriorated, right? Whether my oven is saying this thing is not there. So similarly, my health is there. Can I get your health is deteriorating after 2 days? This can be happen to you. So nowadays people are talking about the early analytics, early whether how much crops will be there, some disease alert will be there. We want alert system, we want warning system, so that this will be how it will be there, because of lot of data will be there, aggregation way this will be connected, and then information will be retrieved, and sometimes we will also have a deep data analytics if huge amount of data will be there. And finally, it is because of the operational technology. because of the sensor connectivity and the information technology to disseminate. For example, when I am saying early data analytics, I do not want to have a false alarm. False alarm, no technology will survive in the market if there will be a false alarm. Another thing is that I do not want to a misalarm. So there is a compromise. The technology should not have misalarm. The technology should not have false alarm. And reliability and accuracy is also important. So my network should be trained. I should have more variability into my data, right? This is only possible because of the edge computing. Otherwise, all the data will be dumped into the central recording station. So ultimately, if equation I will have for the edge computing, it is a function of AI. It is a function of communication. It is a function of computing. Computing is a hardware platform. It can be FPGA based. It can be CPU, GPU. Lot of things are there. So it is a function of AI and computational platform and communication, ultimately disseminating information to the user. So edge computing is also involvement three levels. I'm dividing it. It can be more also, but I am dividing into three levels. That is a low level computation, medium level of computation, high level of computation. So let's understand the requirement, because a application may require a low level of computation. A application may require a high level of computation. When we are talking about the high level of computation, our trade-offs, our computation load will be more, and our latency will be more. Our accuracy may be varied. So for example, low, we are having the sensor analysis, that we want to only have activity recognition, what a person is doing. Only a single thing we are detecting. For example, stress analysis, right? Sensors are there, body area networks are there, they are communicating each other, and then telling only about the stress analysis, nothing else. Predictive maintenance. But if we are having a medium kind of a thing, then we are recognizing something. Object not only detected but also recognized. For example, by the sound signal, we are able to detect whether it is a car or it is a tank or something. And I am not talking about a human. Human can easily distinguish different sounds. But here we are talking about a machine. Machine has to automatically distinguish whether a person A is speaking or person B is speaking, whether it is signal of a car or it is a signal of a tank. So now you see if the application will be more. If we are identifying the tank, we are having a strategic application. If we are identifying a person, maybe of the safety and security of a commercial site will be there, right? Even the universities are there. Even the medical different applications will be there. Now, when there is a high computation are required, high computation, I'm taking an example with the image processing aspect. When there is a multiple object detection is there, it's not only the presence of a single human in a scene. Here we are detecting the multiple object, and also we are classifying okay, whether it is A category, B category, C category. For example, a human, animal, and a vehicle. And then also we are tracking them. So the thing detection, classification, and tracking is required in a real-time fashion. When real-time is there, lot of processing is required and lot of intelligence learning models are required. So now you can easily understand whether application required a low level of processing, medium level of processing, and high level of computation they need. And question comes, why edge computing? When we are talked about this is IoT, this is the computational era, this is the why edge computing is required. Edge computing is required because of the speed, time, and latency. Because example has been given like a smart city. We do not want to wait. We want to decide locally. And earliest we want to take the decision. We do not want to dependent, because there will be network latency will be there and we will not able to communicate properly. Therefore, time, latencies, and speed is very important. Because of that, there is a requirement of a edge computing. And another thing is the cost and volume of data transfer, because cost is not only the money, it is also a computational cost. It is also a hardware cost. It is also the kind of system required. And also how much voluminous of data is being transferred. When we will discuss, I will discuss one or two slide, how much continuous 24 into 7 data is being transferred. So that is very important. And then is a privacy and regulation compliance. Medical equipment, medical data is there. So when we are having medical data, then privacy is a concern because that data is related to a particular patient. But we want to use that data for our research. So ethics are there are the regularities are there, how to maintain the privacy of that data. Now we are taking the two examples. One, where when no edge is there, intelligence is there. Another thing, when there is a smart partitioning, edge nodes are there. You know what we will do in the no edge case, all the data, sample data, then they will send, then they will store, and then they will be analyzed in the center recording station, right? So there will be lot of full data storage, full data bandwidth, full data samplings are there. But let us take an edge. So when we are having edge, we are partitioning this, what is to be stored in the edge level, what is to be stored at the center level. So what we are going to have, we are going to have a triggers, we are going to have a alerts, we are going to have a decisions, and with the reduced bandwidth, because now we are not transferring whole amount of raw data. We are only transferring the processed information. We are only transferring the required information to the user, right? So that is there. So you can see the edge node. If we will have edge computing, definitely we can have filter the interpret the process. We can only measure the critical data. We can maintain the privacy. We can improve the latency. We can do a lot of predictive analysis with the reduced storage and reduced process. Next question comes, what are the motivation and what are the challenge and what are the opportunities? These are very important aspects. Whenever we are saying of any technology, why this is, what is the motivation, what is the challenges? So this is very important thing. So motivation is that we are not talking about the centralized thing. We are talking about the decentralized one, right? So somebody is writing on my this. May I request, kindly don't do this. So decentralized cloud is there. And another thing is that there is a limitation because resources are limitation. So we want only the required information will be there. And then dealing with the data explosion, lot of network traffic, congestion will be there in the data network. So we want to remove that because we are talking about a smartness, so smart city, smart optimization, lot of things we are talking about. Therefore, there is a need to develop a smart computation technique also. But what are the challenges? Challenges are for the electronics people that they have to make a general purpose computation nodes, right? That will process the information. Then another thing is the partitioning the and offloading, which part to be center recording station, which part to be processed at the edge level. Then quality of services and also secure publicly. But opportunities are there, benchmarking and marketplace, framework and languages, there may be sign languages, lightweight libraries and algorithm need to be developed, micro operating systems, because it is a part of a device, right? We cannot think of a big kind of operating system, only the particular thing which is required. And ultimate thing is industrial academic collaborations. This is very important. Now, again, question comes, what is the need of an edge computing? This is the data I have taken from the Microsoft side. And it is a really, you can understand the need of edge computing. See what it is saying, there is a, China is having 100 millions of surveillance camera across there. Now you think if 24/7 data is being generated and dumped into the server, now you can understand a huge amount of months of together data will be there. And for every 8 people in US and also for every 29 people worldwide, that much surveillance cameras are there. And you are aware of that, this Delhi is there, lot of cameras being placed. So continuously it is being, or person is sitting in front of that. But here we are talking about no human intervention. When no human intervention will be there, now you can easily understand what is our target, what is our application, what we are going to detect, what we are going to classify, what we are going to report. Because ultimately automatic reporting will be there, right? So there is a need of AI and machine learning from the data, and it should not be dumped into the center recording. It should be at the different regional level of edge computing are required. Now you see another need is there. What kind of CCTV camera is there? They are only looking for a, for example, take a mall. A CCTV camera is only looking at the door, right? So if a person is entering, it is only capturing. Now I am saying it should have an intelligent algorithm to detect the suspiciousness of a person. If a person is considered as in suspiciousness because of the different features and AI into it, now it should not track to the that door. Now it should track to that people. So it should have a mechanism so that it can rotate. It can now only record the movement of that person only. Another thing is that, for example, take off in an airport where some unwanted things are being placed. How to locate that thing? Crowd analytics and management. What a youngsters are thinking, how they are communicating over the web, how they are communicating over the media. Right. This is a requirement of a and intelligence agencies. And you know, huge amount of data being generated, 10 GB per hour. Do you think if 24 into 7 we are capturing all the data, how much data will be there? There will be bandwidth limitation are there. Then human availability, how to process that data. Sometime it will become a mesh and people are not able to process that data completely. So therefore, there is a requirement of a autonomy. There is a requirement of a autonomy, understanding, detection, classification, and then only processed information to be stored along with data. Now, see, we talk about the smart city. When we are saying smart city, it means if congestion will be there, automatically a person coming towards it, it should be reported. If this part is having, you can take left or right accordingly. But how it is possible? It is only possible with the edge computing. See, if we want to count the number of vehicles enter, again, this is a challenge. If continuously congestion is there, to whom we call a congestion, how we are going to have it? There should be a locally processing unit is there, then only we will report. Otherwise, it is not possible that continuously we are dumping data of every street or every road to the center recording station. Now, you know, we talked about the identity IoT, which ID is there, which street it is belongs to, which place it belongs to. So a lot of GPS things should be incorporated. So what are the key benefits we are getting from the edge computing? We talked about IoT, we talked about edge computing. What are the key benefits? The best thing is that we are getting a faster response time because of the processing locally. Then there is a reliable operation even with the loss of connectivity. If some node is not working, another is being communicating. Then security and compliance is very important because data is locally available with the device. Only the required information, which is the agreed protocol, it is being transmitted. And another thing, there will be a lower capital cost and operational cost. This is very important because operational and capital cap EX and op EX, that is operational cost and capital cost is very important. Then interoperability between different modern devices, and also the scalability according to the location. So ultimately, we are saying edge computing between the device and the cloud computing, and fog computing with the edge, it is there. So the you see, if we are going from this people and IoT, it is also internet of edge to cloud. Then there will be centralized, there will be latency more will be there, processing power will be there, storage capacity will be there, and remotely it will work. But if we will come down towards this, the things will be distributed, the higher bandwidth will be there, energy wise will be better, responsiveness will be better, and privacy will be better. So accordingly, you can see which thing you like. You want to be more centralized, you want to be more distributed, you want to have a latency compromisation, less bandwidth. What is your requirement? Ultimately, you can decide. So now this is very important aspect of application I want to discuss with you, because application with the edge computing and application with the IoT, how it is very important. There are n number of applications are there, which I am going to discuss one by one. It may be I have taken from environmental sector, I have taken agri sector, I have taken medical sector, I have taken from so many sectors. only to tell everywhere there is a need of a computer people. Everywhere there is a computer student can interact and connect. For example, take this intelligent potato storage system. Not only potato storage, intelligent storage system is a requirement. You know, lot of grains are there. You know, lot of onions are being wasted because of non-availability of that. You might be aware of that in MP there happens things. The onion was sold at a 2 rupee, even 50 paisa or 1 rupee kg once upon a time. And once upon a time in North region, you are aware of that it is 100 rupee kg. So why? Because of this non-availability. Then government decided to procure at the rate of 7 rupee per kg from the farmer. And lot of dumped of onions came to the government. In between there was a rain and all of the plan has been wasted and they have invested 700 crore rupee for that. Now, instead of that, if they could have an intelligent storage system, maybe at the one time of investment, futuristic can be taken care. Why intelligent potato system I am talking about? Sometimes they are having very good production of potato. And nowadays potato is being preserved in a cold storage for a 6 month maximum duration. But I am talking about a system which can preserve not only 3 years, even beyond that, without the rooting, because the green part is being there, or sweetness of the potato. Because if sweetness of potato will be there, then it will be of a low cost. But how we will come to know? We need to understand the humidity level. We need to understand the CO2 level. We need to understand the temperature level. You can see the individual storage unit where the different sensors are there and they are having no human intervention is there. ANN is there. So ANN is automatically deciding whether to switch on the humidifier, switch on what do we do. Automatically it is deciding so that they can preserve the shelf life of potato even after the 3 year, same quality which is being retained. So this can be extended to many applications. Then this is very important. I want to discuss with you that is smart clothing, the future patient monitoring, or now you may not call a patient, you may call it a customer or health management also. So I have seen this slide in 2009 in Germany when I was doing research in Germany. So you can see this. I am talking about a smart clothing mean a cloth is having textile into it. A seat belt is there. So whenever we are sitting on a car, driving a car, we are not aware of that whether some sensor is being monitored us or not. We are sitting on a chair, car seat. The seat surface is having electrode, inbuilt electrode, and the belt is having electrode. And when we are touching this uh, steering also, steering is due to skin impedance and temperature. Now you see middle of the dashboard, there is a health index is there. That is the Mercedes in 2009. When its pulse rate and other thing is very high, it automatically alerting you are not fit for driving. Finally, do not drive. Now you think that can be extended to a person who is drinking, right? Instead of some sensor will be there, wine sensor is there. If there may be a sensor which automatically will tell a person is heavy drunk, and even for example, if a driver is feeling sleepiness, then automatically alert will be generating. So that kind of technology is required, right? It is with the integration of technologies. And now, for example, a person is going, he want to have its blood pressure being monitored, sugar being monitored. Now, why? Because I am working continuous day, 24 into 7, and electrodes and other devices are there. My mobile is recording. If it is there, then automatically it will send to the doctor. Otherwise, 24 data will be stored here only. Even the chair on which I am sitting may have electrode and interfaces. Now, accordingly, this will be there. So this kind of a device where personal device is more required. And now smart city, because we started with the smart city, we want to have a structural health of a building. The big mall are coming, the these bridges are there, right? Even the big buildings are there. We want to have automatically structural health monitoring of a building. So we want to establish a wireless sensor network. We want to have a predictive modeling. We want to have a different kind of a element analysis so that we can know how much optimization, how much sensor to be placed, what model to be derived, how we will say if this structure is good. Now, when we talk about the structure, it means first we have to detect the there is a damage in the structure. Another thing is that now we want to identify exactly where damage is there. Now third thing is there, we want to quantify whether that damage is acceptable or some retrofitting is required, or this building is not ready. Nowadays green buildings are coming. Green buildings means they are having sensor inbuilt. It is mandatory. Metros are there. No metro can be built without the inbuilt sensor and all the computational model. Then waste management, air quality. This is a new project people are submitting for monitoring the air quality. Take example of a Rajiv Chowk. Huge amount, it is in the basement, huge amount of crowds is there, noises are there. So the question comes is that what is the air quality inside? But the CPCB, the Pollution Control Board, they are saying people are coming with a proposal to monitor the air quality. But the question is that if air quality is bad, what to do? That kind of thing is also required. Noise monitoring is there because trains are moving in a tunnel. If noise will be there, whether the tracks will be formed over the time. So that also computational model require how to reduce this. Again, a mechanical kind of a problem is there. Traffic congestion, as we have already discussed, okay, we want online traffic congestion is there. How to we come to know that traffic congestion is there. Smart lighting, this lighting is very important. Smart lighting, the European Union, they have already adopted this technology. Okay, with the night time, the light patterns are changing. If it is a bridge, different kind of a pattern being and light being illuminated, and it is automatically, and pattern is automatically being changing. There may be different kind of thing are there. So this is giving a good boost because of the IoT based system. So we are going to have a prediction, we are going to have early warning. So prediction, you are aware of that N sector, early warning also in the N sector with the computational intelligence and computational tool. So ultimately what we are going to do, we are going to have a SIM fold. SIM fold mean C for control, either we are controlling something or we are inspecting something, we are monitoring something, we are predicting, forecasting, recognition and diagnosis. The different application may have a different kinds of a thing. So this is a ultimately prediction versus early warning, and it required lot of data, ultimate data, and also the connectivity, data mining, and knowledge base, not only database. Now people are not talking about the database, knowledge base. And this is a very new and intelligent and really needed kind of a system that is known as a artificial organoleptic system. You are aware of that we are having different kind of a senses, right? Taste buds are there. Here I am talking about e-nose. Here I am talking about e-tongue, right? When I'm saying e-tongue, so we are tasting either sweet, sour, bitter. Smell is also there. So can we design a e-nose kind of a system? Can we design a e-tongue kind of a system? How to do? For example, e-tongue. A tongue is having different kind of a taste buds are there. So that test buds are telling us these are sweet, sour. So these are to be replicated with the sensors array. So we need to have a different kind of a compositions. Here, computational model before designing, chemistry people should sit with them and electronic people, they should come with this different kind of a coating that if any of this thing is there, we are getting signal in brain. For example, sweet is there, we are getting signal. If sour is bitter is there, we are getting signal. So from these sensors, now we should get the different features. That feature in form of a data, in form of a quantity, in form of some mathematical model, right? Then our neurons are different danglings are there. You are aware of that. They are firing of a neurons, right? If threshold is higher, they are fire, otherwise they are not fire. Similarly, the pattern recognition from the data, we have to identify, we have to compare with the already generated knowledge, or we have to correlate with the knowledge already established so that we can classify different results on the basis of the training. So artificial organoleptic system is a different model where computer science student can work. And this is having various applications in the beverages. For example, the quality of a beverages, the quantification of a tea, adulteration of a milk, adulteration of a water, adulteration of a oil. You can have an n number of application with this single slide only. Then intelligent e-health center. This I want to specifically explain this thing. Uh, if you permit me, I want to show one video. If it is possible to, is it possible?
Yes, sir. You may please.
So I want to share one slide.
Yes, you can.
So I am stop sharing, then I am coming with that. Mm, okay, okay. Are you able to see the desktop?
Yes.
Are you able to see this?
Yes.
Okay.
Yes, sir.
My father taught me to believe in every seed that we put into the ground, that every dream could become a reality. So he borrowed money, bought many bags of seeds, rented more land. When the big harvest comes, he was going to buy a tractor. Day and night, he hurried to prepare the fields before the clouds came. And then days passed. Everyone in the village had given up. There's medicine in the town far away, but we have no money left. That was no ordinary day. We did not know our lives would soon change forever. As my father says, nothing is impossible if only we can hold on to our faith. Who could imagine that one day a medical center could travel to our village? Do you even think that doctors would speak to us from far away? the health center, they taught us how we can prevent spread of disease and lead a healthy life. Who could have imagined my father would gain his strength to hold the plow once again? The seeds were spread just in time, and then it poured, washing away all pain, all sorrow.
So why I am saying, is it now my PPT is visible? Hello.
Yes, sir. It is visible.
So
Yes, it is.
this project we have done in the Chosalla village of Kathal, because it's very near to the Hisar, and we have taken doctor help from the Agroa Medical College, because you are aware of that sometimes doctors are not coming. So on the daily basis they are coming to this hospital. Chosalla village, they were not having even the registered medical practitioner, right? Now they are having a very senior doctor is continuously visiting there, and their attendance on the cloud base, it is being marked in the Delhi because everything is on the cloud. And we have generated huge amount of data because 3M and HP came together, and we have gone to the person to person and identify past histories, and then generated certain kind of a pattern. Why this project was taken? To show the prime minister, okay, if some disaster will be there, like you might be aware of that in Uttarakhand, there was a lot of disasters were there, all building was washed out, but this can be airlifted because everything is inbuilt: the testing center, the operation center, and the medicine and doctor consultation room, all the connectivity, everything is inbuilt, so they can be airlift and within no time doctor can start work. And another thing you have observed, the person, every data was digitized, so sent to the cloud. And one more thing, IoT, you have seen the SMS was received to a person that you are having next appointment. So that kind of a intelligent e-health center is also the need of the hour. And you see, this is the lot of containers are available in the country. These container can be converted into the e-dispensaries with the good networking. The hospitals, the you can say even the schooling, even the houses, lot of things are there. So next, also the edge computing. Kindly let me know, because I can have more applications I can discuss. Let me know when to stop, right, as per your time permit. So shall I continue or
मुझे मुझे लगता है क्वेश्चन आंसर पे चलना चाहिए.
okay? So we can, if it is like that, I can stop here.
क्यों जय भगवान, ठीक है.
हाँ जी सर.
मुझे
थोड़ा
लगता है
सा.
कि बच्चों को
हाँ.
थोड़ी क्लैरिटी, और मतलब जो स्टूडेंट्स हैं दे कैन आस्क क्वेश्चंस.
जी
Sure,
जी
sure,
जी.
the way you want. Or I can go in a one skill, different kind of application with a 5 minute complete all the application.
ये आप कर सकते हैं, that if you really
Yes sir.
Okay.
would like to complete, then you take me another 5 to 7 minutes.
So
And
five,
then
7 minutes, quickly I will run my own presentation.
okay,
So
okay,
you
no
know,
problem.
edge computing for the humanity, because you are aware that Alzheimer is disease is there, autism is there, and also for the elderly care, a lot of technology and AI intelligence is required. Because wearable technology for the elderly people, so that we can come to know their different activities. Because you know there was a problem in a bigger cities where the single parent is there, and if child is staying abroad, in 17 days a dead body was lying in a room, even a child and neighbor were not aware of that. That technology can be there. And if a person is in the office, they will also take care about their elderlies. So even the this, you can say, specs is there, which is having pulse glass, so that they can identify different kind of a signal, whether walking, sitting ideal for a longer time. Similarly, belt kind of a system is coming, so that people can correlate different kind of falling state, walking state, and also the human activity recognition, what a person is doing. So that is also AI, different kind of a recognition detections are there. Similarly, there is a new one research I have observed from one paper, that is a handshaking detection system. If a person is handshake, then how automatically we will come to know, we will tell some kind of a degree movement automatically from the signal we have extracted the information and trying to train the network. Similarly, if from a car, how automatically, if camera is not there, we will come to know a person is drinking or he is turning a page, different signal it is extracting. so that it can train its network and classify differently. Similarly, scene understandings are there. There are again a low level computation, middle level, high level computation. Low level mean only we are detecting the presence of a person. Segmentation at the middle level, so that we can identify there is a water is also there, river is also there, and mountain is also there. And high level is there what this scene indicate, whether a person is looking to the water towards it, what exactly it is there. So similarly, this task-specific assistant cooking Google glasses are there. So this is recognizing even for the blind person it is being there. And futuristic autonomous vehicle are there. You are aware of that, how Google car is coming when no driver is there. So it means it will take care for the congestion and all views will be there. And this is a drone-based fault detection system. Automatically, big power lines are there. So automatically they not only detect but also classify differently. And this sniffer dog for trap body detection. I think I should stop here and now over to you for different question.
Thank you,
Yes.
sir, for grooming us to the sound professional with knowledge of IoT and edge computing. And thank you for sharing so much of application from remote monitoring medical and equipments, from autonomous car drive, from artificial sounding, as well as artificial sensoring, as well as you have shared applications based on like the starting one that we have just shared on. So it looks like we have covered lots of applications. So students are requested to pop up their questions in the chat box so that we can share the questions regarding your queries over here. So there's a question from Jay Prakash. He's asking, PLC and SCADA uses internet and server. Is that IoT?
See, SCADA is very important. When train is moving, right? Take example of a metro. Okay. So if some earthquake is coming, right, warning is being generated. So one thing is that human intervention is there. They will give signal to all the persons. One SCADA is that automatically they will activate the stoppage of an train, so that some breakage will be automatically applied and they will come to the safe stage. Similarly, for example, there is a production of a power plant, there is a production of a nuclear thing, there is a production of an refineries are there where gas is bottling plants are there. So instead of human intervention, if SCADA will provide the automatic on detection of a abnormality, on detection of an event, automatically some insertion of road is there. So it means we can delay the disasters. That is also an IoT based thing is there.
Okay, sir. Thank you, sir. Um, I think students, please type your questions in the chat box if you have related to it. Sir, can we just wait for 1 minute so that students who are typing?
Sure, no problem.
Yes.
Yes.
Any student who is working on IoT?
Not only this, detection, classification, image processing, even maybe the signal level or sensor network, communication, whatever you want to ask, you can ask.
Yes, sir, I just asked one question. So, what is the meaning of WSN, the wireless sensor network? Is
Wireless sensor network.
it same as IoT?
See, wireless sensor network, if it is disseminating the information, right? For example, if take the example of a structural health monitoring, right? Or take the example of a body area network, right? So if different sensors are there, if they are wirelessly connecting. But the next level is there, that is considered as WSN. But the important is that whether it is communicating, disseminating information to the user with some set protocol, it is having some computational into it, it is having some interfaces into it, then only it will comes to the IoT. Otherwise, it will be simple WSN. So
Yes,
it is the next level, second level and third level kind of extension to the WSN.
so you have talked about the autonomous car system. So is Tesla, the car which has been put on, is it is also based on IoT?
See, IoT is there. See, it is taking connecting with the different kind of a server, right? It is automatically taking care sub scene. It is having inbuilt analysis, right? Automatically congestion, then also the object detection. Automatically, n number of things is being computed. Sensors are being integrated, right? Over the line, right? Even sometime it is taking help of the location or some time of server also. So if connecting together, if independent, if car is there, it may not be IoT one, but if it is connected to a smart kind of a network, then it is considered as an IoT based system.
Sir, I think so. Students have no queries till now.
No problem. I think then propose vote of thanks. Do they?
Yeah.
Okay, sir. It looks like we have covered all the question. And sir, is there anything you want to wrap up? Else we can
before
just have a
before
vote of
that,
thanks.
I'm really thankful to all of you, because the both the Professor Dharmender Kumar, incubation in charge as well as chairman, and Jai Bhagwanji, also to Devansi, and to especially thanks to all the participants who listen and given so comfortable environment, so that at least I can deliver the lecture in a really good thing. And I'm really thankful to all of you who is connected, including VC sir, to all of you. Thank you very much.
Thank you, sir.
For joining us today. So I just now want to invite our assistant professor, sir, of CSC department, Professor Jay Bhagwan, sir, and I want to say that he please conclude and give a vote of thanks to this event.
Thank you, Devanshi.
Thank
Am I audible?
Yeah.
Yes, sir.
Yeah. Good afternoon to each and everyone. It is my privilege to propose a vote of thanks today for this webinar named as Computing and IoT. First and foremost, I would like to thank to the Almighty God, uh, because of his or her grace, we could be able to successfully finish this kind of such a beautiful, session. After that, it is my pleasure to it is my immense pleasure to give my sincere thank to the honorable speaker Dr. Satish Kumar, who told us that recently only traditional computers were used for the computing, but now you have broke the boundaries, and nowadays the as computing and IoTs can be used in each and every field, like biology, chemistry, mechatronics, computer science, medical field, optical engineering. He also gave beautiful examples like e-car, intelligent car, and suppose a driver is driving a car which is going to be sleep. Message can be generated. Uh, it is just because of IoT. Thank you, sir. It was very wonderful session. Now, I would like to pay my sincere thanks to our Honorable Vice Chancellor, who spared his precious time with us and told us that today's topic is very important for the students, because it is having a lot of jobs and every student must be aware about these kind of technologies beyond their classes. Next, I would like to thank Professor Dharmender Kumar, Director, PDU IIC. Sir, you told us the examples and the benefits of the edge computing and IoTs. You said that smart cities and home appliances are there, which could be able to make our life easier, and people from various backgrounds can collaborate in order to work together with the edge computing and IoT. It is a world where no human intervention basically. So it was very wonderful to hear from you. Now I would like to pay my thanks to the chairman of the department, Professor Dharmender Kumar, who provide us a platform to organize such a beautiful and knowledgeable webinar today. At last, I would like to pay my sincere faculty members and the students who play their beautiful role directly or indirectly in order to handle this webinar. So thank you so much.
Thank you.
Thank you. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank
Thank
you,
you,
Dr.
sir.
Satish.
Thank you, sir. Thank you. Thank you all.
So we may sum up.
Yeah, yeah. So,
Okay, sir.
okay, okay. Thank you all.
Thank you.
Thank you, sir.